Hello everyone, my name is Tiago Oliveira. I'm a DEVOPS software engineer in accelerator controls at CERN. And today I'll be presenting improving the CERN Control and Monitoring platform, also known as C2MON, with Apache Ignite. I would like to mention that everything I'm presenting here reflects mine and my team's experience with Ignite in this project, as I cannot make statements on behalf of CERN as an organization. In this presentation, I will start by briefly introducing CERN, for those who are not aware, followed by an introduction to C2MON. Then I'll explain the steps we took to migrate to Apache Ignite, and then I'll go a bit more in depth into the Apache Ignite configuration. Starting with the introduction to CERN. So CERN is the largest particle physics laboratory in the world. It's situated in the border between France and Switzerland, and it hosts the Large Hadron Collider, also known as the LHC, which is the world's most powerful particle accelerator. And if you look at the image, you can actually compare its size with, for example, the airport or the lake or even Geneva. So at CERN, we are more than 70,000 people from all over the world, from which 2,500 are employed by CERN, and around 500 people develop software, and a lot of it is used in the CERN Control Center that you can see in this image here. Lastly, in the last image, that's CMS, one of CERN's experiments, and I don't know if you noticed, but that's actually a person. So CMS stands 100 meters underground and it's 15 meters high. Passing now to the introduction to C2MON. At CERN, we have more than 200,000 endpoints, which can come from many different sources like the computing center, cooling and ventilation, the quench protection system, and all of them need to be controlled in the CERN Control Center, as I mentioned before. So what controls all of this data is C2MON. C2MON stands for CERN Control and Monitoring Platform. It's an industrial controls data acquisition for monitoring, control, and data publishing, and it provides high availability and fault tolerance, which makes it a perfect fit to handle all of these complex and critical systems that are present at CERN. So to get the data from all of these sources, C2MON uses data acquisition APIs, and be aware that the number of messages that are received per day can reach up to a few million, and so C2MON needs to process all of them in real time while maintaining data consistency. And this can include the evaluation of tag values, activation or termination of alarms, rule calculation, and evade propagation. C2MON uses a classic client-server cache with a distributed cluster, so in our case, Apache Ignite, which not only helps improving the scalability and consistency of C2MON, but also adds redundancy on the server level, giving us the possibility of doing rolling upgrades, as well as providing instant failover in case of a single server failure. We chose Ignite because, first of all, the previous caching system was moving away from open source, and as a non-profit organization, we try to use open source projects whenever possible. Ignite also supports Java 11 and up, which was not the case with the previous implemented caching system, and it's also very scalable, which is crucial for our use case. Passing now to the architecture of C2MON. So, as I mentioned before, we have the data acquisition layer, which provides solutions for acquiring data from a different number of protocols. And we also have clients, which provides service classes to interact with the server. And finally, the server architecture is designed around a distributed cache, which keeps for each configured sensor the latest value in memory. All of this is communicating through JMS, and although we use JMS, there's no direct integration with Ignite, as the caching system is completely abstracted from the rest. And finally, we have also a database to store historical data and to preload the cache on startup. So C2MON is developed in Java, as well as all the data acquisition and clients. And currently in production, we have 2 instances of C2MON and 2 Ignite nodes. And these nodes are connected through TCP, forming a cluster. Currently at CERN, we run most of our production software in bare metal. So in our case, if one instance goes down, with the help of Ignite, this is transparent for the clients. And this way we can achieve almost zero downtime. Although we deploy most of our production software in bare metal, it's also possible to run C2MON in containers and also Ignite. And this was very useful for integration testing, where we could use test containers. Now I'll explain the steps we took to migrate to Apache Ignite. So first of all, C2MON previous caching system wasn't implemented using the best principles, And so the implementation was very tightly coupled, making this migration hard. And so the first step was to reuse the existing interface from the previous caching system. The interface you see here, called cache, was previously implemented by all caches, so we decided to use it and then add the Ignite caching implementation underneath. Obviously, this reduced our ability to use the full power of Ignite, but gave us the possibility of completing abstracting the caching system and making it possible to also implement other caching systems if needed. For example, we also implemented an in-memory cache, which basically just uses hash maps. And this way, C2MON is completely loosely coupled from the caching system, and the implementations are transparent. Cache queries were also present in various places throughout the code, and so the first step was to replace them with the interfaces, and then we could add the different concrete interface implementations we required. If you look at the examples I gave, for example, for tag queries, we had to also find tags by name and by wildcard, and so underneath we just implemented our Ignite implementation as well as for our in-memory cache. The same goes for example, the alarm queries and all the other caches. The first obstacle we found was actually implementing these queries. So we started with the Ignite scan queries because they are more flexible, since filter and transformer can contain arbitrary code, but they perform full cache scans, so they do not use indexes in any way. And we actually found that they had very poor performance. And just to give an idea, when we did our cache warm-up on startup, C2MON was actually hanging because this was so slow. And in here, I have an example of the code I use. So basically, I just use the Ignite by predicate to pass the filter and then pass to the Ignite query. But as I said before, this was performing very poorly. And the solution was then to use SQL queries. This has the disadvantage that every field that we want to query by needs an additional configuration of queryable fields. For example, for data tags, if we want to query by equipment ID, we had to add this additional annotation, and also for the other fields we want to query by. But this gave us the possibility of using the full power of SQL. If you look at the example, we use the SQL fields query, and then just pass the SQL query. And in here, we can just use joins, aggregations, or even groupings. And this had much better performance, obviously, when these indexes were correctly defined. And just to give an idea, right now in production, we have more than 400,000 of heap entries, and we could achieve an average get time of 4.1 milliseconds. Passing now to the Apache Ignite configuration we used both client mode and server mode. Obviously, in production, we use client mode because it's much more flexible, and we can just have the Ignite cluster outside of C2MON, and it's also more scalable. But the server mode was also very useful. In this mode, when we started C2MON, Ignite would automatically spin up in embedded mode, and this way we didn't need to have an additional cluster just to perform our integration testing or even local tests. Regarding data partitioning, we used partition mode with one backup, and in this case, all partitions are split equally between all server nodes, as you can see in the image. And although the reads are a bit more expensive, the updates are less expensive. And we also use replicated mode, where all partitions are replicated to every node in the cluster, as you can see here, and it provides the highest availability of data. Although it might impact performance, we couldn't actually see this with C2MON, so this is actually the mode we use in production because it provides the highest availability of data possible. Regarding Ignite persistence, we had to find a way that if the Ignite cluster goes down completely for some reason, we needed a way to recover quickly. So in this mode, Ignite stores all the data on disk and then loads the maximum amount of data into RAM. And then we decided to add some logic in every cache operation to wait for the cache to come back up, obviously during a reasonable amount of tries. And this way, the cluster, when it comes back up, we saw that C2MON recovered and it returns to its normal state. This mode is also useful because we don't need to preload the cache every time as we do on startup. If you look at the example, basically in this put operation, if we get an exception that when the Ignite cluster goes down, we wait for a maximum amount of tries, and then when the cluster comes back up, C2MON just recovers and goes back to its normal behavior. We also decided to enable GMX metrics and statistics, and this was very useful also to connect to Grafana Dashboards. Currently, we use the Open Census library in Ignite. So with the examples I show, as I mentioned, we have 2 nodes of Ignite right now running in production. We can also see the off-heap percentage that we are using. There's also the cache entries for each cache and for each Ignite node. And this was also very useful because when we deployed the first time in production, there was one Ignite node that was actually not getting any data because in the end it wasn't still active. But basically, just to show that with these dashboards, it's really easy to see how Ignite is performing or if something is wrong. Another interesting dashboard is the number of cache misses, and this should always be at 0. Otherwise, Ignite might not be in the best state and something is wrong. And also, it's also useful to see how the storage size evolves over time. So in conclusion, we saw that C2MON is a critical piece of infrastructure which needs to run 24/7, 365 days a year, that scalability, consistency of data, and rolling upgrades are crucial, and that the integration with Apache Ignite helped us achieve those goals. The fine-grained configurations that Apache Ignite provides makes it easy to optimize and fine-tune the application behavior. Feel free to get in touch if you have any questions through my LinkedIn, and thank you for watching.
That was Tiago talking about his experience using Ignite at CERN. So welcome back. Thank you for that talk. It was I always find it fascinating to kind of learn how people are using Ignite in the real world. And one of the wonders of open source is even though I work for GridGame, we don't often hear about these stories until events like this. So I'm kind of super happy to hear about it. So I don't see any questions in the chat yet about it, but we've got a couple here. So if you have questions, please feel free to put them in the chat. It's not too late. There's a couple of questions I have from some of my colleagues here. How is the data from C2MON DB loaded into Ignite?
Yes, so at server startup, C2MON starts by loading the cache from the database into the caching system. So basically to warm up the cache. And so this process is completely independent of the caching system. And so what I mean is that this is not tightly coupled to Ignite in this case. And then we also have a consistency check step. So we can compare the server cache sizes against the operation database, for example. So in here, if we see some differences, we can already detect if there's any consistency. And this is actually good because if C2MON goes down for some reason when it starts up, we can just do these consistency checks. And if everything looks okay, we can just keep the normal behavior, and it's much quicker to start up, basically.
So how do you do your consistency checks? That seems to be like a fairly common problem.
Yeah, so for now, we have a simple one. So basically just see the sizes of the cache and compare it to the database. So if something is like different there, we can immediately know that there's something wrong and we need to do something. So for now, it's just basic, but this can always be improved in the future.
So you seem to have quite high uptime requirements. So you're using native persistence, I think, from your slides. Is that correct?
So yeah, we just have persistence. So basically, Ignite persists on disk. So in case it goes down, when it comes back up, this is it's easy to start up, and so we don't lose the data, and we don't need to warm up the cache every time we just start up C2MON.
But you don't have to replicate it to a different cluster or anything like that. It's just one cluster with resilience.
Yeah, just one cluster with 2 nodes, so in different machines, and so even if one goes down, we don't lose anything, and we can keep going. And yeah, the same for C2MON. We have 2 instances right now running, so we have this redundancy. Yes.
So how did you arrive at the list of metrics? Because you got some really nice Grafana dashboards there. So how did you kind of arrive at the metrics to look at?
Yeah, actually, yeah. So we enable metrics because it's always good to have this information on the dashboards and everything. So to get it, so the system we tried to use first was the GMX exporter, And we actually saw, we got a bit of trouble because in the newer versions, we were getting some exceptions. And then with the older versions, we actually had some memory management problems when the persistent was enabled. So in the end, we used the Open Census exporter. So this is what we use currently in production. And there's also documentation about this on the Ignite documentation. And so basically, we just had to compile some binaries, and then the configuration was pretty straightforward. And then once we had Ignite exporting these metrics, it was just a matter of adding this new target to Prometheus, and then we could then create some dashboards. And yeah, with Grafana, as I showed in the presentation.
Good stuff. Well, it sounds like you had some success with Ignite there. That was good to hear. Yeah. Any kind of final words?
I think, yeah, it was a very good experience actually to use Ignite. I mean, even all the configurations, it made our life a bit easier to test everything. And yeah, I just wanted to share my experience. And so thank you for the opportunity.
You're welcome. Really appreciate your time and sharing your expertise. It's kind of what makes the Ignite Summit a success. So thank you.
Thank you.